The Panama Canal was opened to traffic in 1914, before which ships traveling between the Pacific and Atlantic Oceans had to travel about 15,000 kilometers more. The easiest way to build a canal through the Isthmus of Panama would be to dig a direct channel. The French tried this method in 1892, but after nearly 8 years, nearly $300 million and the lives of 22,000 workers due to poor geology and weather factors, the French finally had no choice but to abandon the project. The Americans, who took over, came up with the idea of simply leveling the ground and then building a dam to create an artificial lake above sea level, which would allow ships to cross the Isthmus of Panama with ease. To transport ships up from sea level, all that was needed was to utilize the principle of water connectivity and build multi-stage locks to do so. The ship first enters the open primary sluice, and after the primary sluice is closed, the valves to the secondary sluice are opened so that the water between the two sluices is connected and automatically matched to the same level. The secondary sluice can then be opened to allow the vessel to enter it, after which the above steps are repeated to send the vessel into the topmost artificial lake. Boats traversing this artificial shortcut have to be lowered back down to sea level at the other end, and again this can be done through a multi-stage sluice, with the difference being that it is in the opposite order to the entrance. Engineers first built a dam at the river's mouth to allow the flow of the Chagres to pool in the area, where a new body of water was formed known as Lake Gatun. The next challenge was to open a 15-kilometer channel to connect Lake Gatun to the sea. A lot of the black technology of the time was used here, such as steam excavators, where workers rotated a rocker arm using brackets with steel cables, and a grapple on the rocker arm moved through gears and steel cables, which allowed digging in the opposite way to a modern excavator, and later unloading by pulling on bolted cables underneath. When the wagons were loaded and transported to the unloading area, the dirt was dumped from the other side by means of a steam traction unloader. When there was too much dirt on either side of the tracks, the steam bulldozers came online. The bulldozers on both sides of the front end extend out about 4 meters at the furthest end to widen the space for the unloading area. There was also a steam track changer with a small crane, which saved a lot of labor in laying the tracks. Through more advanced technology, the Americans did what the French had not. In October 1913, U.S. President Woodrow Wilson blew up the Gamboa Dam by sending an electrical signal 6,000 kilometers away by remote operation, officially connecting Lake Gatun to the Atlantic and Pacific Oceans. Today, vessels crossing the river are towed by tugboats as they approach the canal lock chambers, and then 2 tugboats adjust their lateral orientation before entering the locks. 4 electric locomotives will also be connected before entering the locks to tow the boats along the railroad tracks on either side of the locks to avoid collisions with the locks. The boats then arrive at Lake Miraflores, and after a short voyage to the next lock, the boats come to Lake Gatun in the same way, enjoying the beautiful scenery along the shoreline as they go. After reaching the end, the boats are then sent to the sea on the other side by the opposite way of releasing water. The lock gates are in the shape of Leonardo da Vinci's miter joint lock design, a structure that allows the gates to be tightly connected under the pressure of the water, creating a perfect watertight lock that only opens when the water pressure on both sides becomes even.